Good afternoon, everyone. Can you hear me? Yeah, good
Yes.
afternoon. Thanks for joining. So today we have our speaker, Dr. Aziz Shah. Dr. Shah is an associate professor in the Research Center for Intelligent Healthcare at Coventry University in UK. He is an interdisciplinary researcher focusing on advanced radio frequency sensing design and signal processing using radio frequency, especially in the healthcare application. Dr. Shah published over 100 scientific articles and in the top tier journals such as IEEE TAP and IEEE AWPL. Given for and Dr. Shah is very much involved with the healthcare application using radio frequency in healthcare application. We are so honored that Dr. Shah gave us time. He's a very busy person for his talk today. The talk title is Radio Frequency Sensing in Home Health Applications. So please welcome Dr. Shah. Thank you, Dr. Shah, for your time. Over to you.
Yes, thank you so much. Yeah, I'm really sorry. I'm still having some IT issues with my, I don't know, PowerPoint. So just bear with me for a couple of seconds, please. Yeah, I'm really sorry for this.
No, no worries. If you can see, there is a share button at the end. You can click on that, and then the screen will project.
I'm struggling opening my file here. So do you have laptop there? I can send you my presentation if you
Okay,
may open it from there.
you can quickly send me an email. I can project from my laptop.
Yes. So what's your email, please? Can you
Uh, you already sent, I think. Just Bukhari yes at stjohns.edu.
can you send me your email? Let me send it to you.
Did you get that?
Yes. Just bear with me for a second, please.
Okay.
Yes. Can you please check now? I'll send it to you.
Yeah. Not yet. It's still on the way, probably.
Yeah, I think it's loading up.
Meanwhile, you can try on your end here if you can share.
Yes. Yes.
Oh, yeah. We can see your screen.
Can you see my screen now?
Yeah. Yeah.
Let me let me try now.
Perfect. Yes, we can see your screen. Please go ahead. Are you there? We can see your screen. Yes, we can see your screen. Okay, you can stop sharing. I can share on my end. Yes. I'm sorry, guys. So, speaker is trying to log in again. So there was an issue with the mic.
Yes, hello. Can you hear
Yes.
me?
Yes. You can see
Yeah, I'm
me?
really sorry. Yeah, I
No,
think
no,
maybe
it's
I'm
fine. It's
using.
fine. Please go ahead. Yeah, you can just let me know when you have to change the slide so you can see your first slide.
Okay, okay. Thank you so much um, for introducing me. So, um, like my friend has introduced me earlier, my name is Saeed Aziz Shah, and I'm working as an associate professor in Research Center for Intelligent Healthcare in Coventry University. So I've been working in this research center for more than 2.5 years now. Um, as described earlier, my main research interest is using radio frequency sensing for different healthcare applications for in-home monitoring. Like by radio frequency sensing, I mean like using different RF-based non-contact sensors for monitoring activities of daily living, fall detection, wandering behavior, or even like small-scale body movements such as a cardiac activity or breathing rate. So the rationale behind is, so as you're aware that radio frequency signals, they are available everywhere. For example, in our houses, in homes, on campus, hospitals, parks, everywhere, and they are able of monitoring different activities, as I have mentioned earlier. And these radio frequency signals can be used to monitor large scale body movement or small scale body movement, such as like intrusion detection, if somebody is sneaking into your house, or for patient monitoring. Apologies for the typo mistake here, it's patient, not patients. For patient monitoring in hospitals or home or at core care homes, or even these can be used for search and rescue operations as well. So my main focus is on using these radio frequency signals for in-home patient monitoring. So that's the rationale. Yeah, can we move forward? So there are some limitations on existing technologies. For instance, if you use camera-based system for monitoring a particular patient 24/7, say if you are monitoring their body postures to prevent bed sores or fall detection. If you use camera-based system, it might raise privacy concerns. It is it is computationally expensive as well. Extra CT scans or variables, for instance, any patient with dementia wearing wearable sensors, there is high likelihood they might forget to wear, or even like if they're changing clothes or going into the shower. So these are the limitations with current technology. Can we move forward, please? Yes, there was a question. I think someone has sent a message like which frequency range. So the frequency range usually, so I'll discuss the frequency range later on. So there are three techniques that presently we are working on. Number one is Wi-Fi based sensing system. Number second is radar based, and then the number third is software defined radio based sensing system. The first one, like Wi-Fi based sensor system, it uses a low cost ubiquitous wireless devices such as Wi-Fi router that is like deployed almost in every home or residential home or on campuses as well. It is ubiquitous. And network interface caller, already we use it on daily basis in our laptop or desktop computers. And with desktop, all you need is like an antenna. So Wi-Fi router in tandem with network interface card, they form a non-contact RF sensor. Yeah, so these are pretty much like devices that you use for to monitor for in-home monitoring using Wi-Fi sensing. Can you move forward, please? So how these radio frequency signals can be used, particularly Wi-Fi signal, radar or software-defined radio sensors can be used to monitor. For instance, if you can see here to the bottom, say if the person is sitting and we have a transmitter here to the left and receiver here to the right. So you might be aware the radio frequency signal, when it propagates from transmitter to receiver, it propagates through different physical paths. Say number one, in line of sight direction. If the person, say, is sitting on a chair, so there will be some signals that will be received in direct line of sight. Say the one in the black. Some of them might strike a wall, a ceiling, or a floor. similar to the one in blue, and some of the signals will directly hit the person and will be deflected and received by the receiver. So you can see like here in this example. So the signals that are received when the person is sitting are black, blue, and red. But as the person moves from sitting position to standing position, the signal propagation path changes, and the received signal is also changed. So, say like the one in black, blue will remain the same, and as the person like transits from sitting to standing position, the red signal becomes blue, like because the signal propagation path changes. And so if you combine the signal that are received for sitting position and combine the received signals for standing position, they will be distinct. So this is how you can infer like different human activities of daily living. So you can see from here, the signal that are received in sitting position will be different from standing position. So that's the whole idea or rationale behind using radio frequency sensing. So this is one of the examples, typical setup to the upper right side. So we have a Wi-Fi router, and then the person moving like back and forth, performing different activities. And so there's a desktop computer connecting. So this is how we conducted this experiments a few years ago, just to see like, and our idea was if we are able to pick up like a particular disease symptom experienced by Parkinson's patient, that is called freezing of gait or fog. You might be aware in freezing of gait, the Parkinson's patients all of a sudden, when walks like in indoor environment, experiences as if their feet are glued to the ground and their upper body tries to move. So this is called like the freezing of gait. So what we wanted to do, we wanted to distinguish like the voluntary stop from freezing of gait. So the participant were asked to perform like different activities: voluntary stop, sitting, standing, walking fast, walking slow, and freezing of gait. So you can see visually here as well, like without applying machine learning algorithm, visually the Wi-Fi router um, uh, gives us a unique imprint for each body movement. So this experiment, because we didn't like perform these experiments on actual Parkinson's patient, we asked the volunteer to mimic these activities. So these were performed in a well-controlled environment. Or even all of the examples I'm going to give you, all of them are in performed, the experiments are performed in a very well controlled environment. So this is like the first application, the large scale body movement, like I said, sitting down, standing, a fall, moving back and forth, freezing of gait. This is the example with Wi-Fi router. Moving on to another application of Wi-Fi sensing for small scale body movement, that is detecting the subtle chest movements. Can you move forward, please? So this was respiratory detection. So what we did, we put a variable reference sensor on a person's chest, and then between the transmitter and receiver, the transmitter that was used a Wi-Fi router, and then receiver, of course, a laptop computer embedded with network interface card. Then the voluntary was asked to first perform like normal breathing and then stop breathing, and we wanted to see if we will be able to pick up a particular respiratory condition, that is sleep apnea. To the top left, we have the raw Wi-Fi signals that we have received, and we have picked up one Wi-Fi signal to to check if you are able to pick up a breathing pattern. So here to the bottom right, we have the person who was performing normal breathing, and then he was asked to stop breathing and then normal as well. In the middle, we have this filtered breathing pattern that was recorded using reference sensor, and then to the right one, that is signal that is received using Wi-Fi signal. So you can see there's quite synergy between these two signals, and at the same time, the person, both like the reference sensor and then the Wi-Fi sensing both picked up the sleep apnea at the same time. Yeah. So I haven't shown the other results like performing cross correlation, but I just wanted to give visual representation because I'm not sure how many of in the audience are from engineering or computer science background.
Yeah, we are mixed.
Okay,
Thank you.
it's a mixed bag. I mean, that's fine as long as we don't have non-technical background. So I thought there might be someone from healthcare background. So that's we all are on the same page here. Can we move to the next page, please?
Yeah.
So these are a couple of examples. What the large scale body movement like activities of dealing? The second one was small scale body movement. Moving on to the next sensing technique, that is the radar sensor. The first one was Wi-Fi, and there's third application. We can also use radar technology to monitor the same like activities of daily living and also detect a different respiratory rate. So we have to the left. These are all like different radar sensors, low cost. These are like some of them are even like quarter of the size of a mobile phone. Some of them are as large as mobile phone. So quite like these are all low cost, a small radar sensors that we can monitor for respiratory. So you can see like these are different time frequency spectrograms generated. So you can see like even similar to Wi-Fi sensing, the radar sensing also the human activities. It also induces a unique imprint the on the radar signals. Um, I'm not able to see it, but can you zoom out, please? Because so these experiment we yep. Can you zoom out? Yes, this one. So you can see the one in the right on the bottom right side. So these are different activities, and this is for the fall. So what we did, we asked a healthy volunteer to fall on the ground, and we wanted to pick up the fall activity, and also we wanted to test the machine learning classifier in tandem with radar sensor. If you are able to pick up like similar activities, by similar I mean if you bend down to pick up something, or if you bend down to tie your laces, or even fall as well. So three of them has forward acceleration, and these are all similar activities. But even radar can even detect like these intricate difference between similar activities. Like I said, a fall or bending down to pick up something or bending down to tie shoelaces. So yeah, that's pretty much. And this one like breathing pattern. Sorry. So we can come back to question and answer at the tail end of presentation. Can we move forward, please? Slide number 8.
Okay.
Yes. So the third one, this is the ongoing PhD project we are working on. The third one is software-defined radio, because radar sensing and Wi-Fi sensing both comes with like good and bad. By Wi-Fi, by good I mean like yes, it's low cost, it's ubiquitous, present everywhere. You don't do not need any dedicated device. But the downside is um, the results or the performance sometimes is it's not reliable, particularly if there is like slightly change in physical medium. Say if any monitored person, if you're monitoring any specific person, and a person you don't want to monitor, and if he's roaming around in the area as well, so that might raise false alarms as well. Similar to radar as well, yes, it has advantage like um, the movement in surrounding or the clutters sometimes like because the beam is very narrow, so the movement in surroundings sometimes wouldn't affect because the beam is narrow and it only sees in line of sight. However, because the radar can only detect activities in line of sight, so any activity in non-line of sight or at the corner of the room goes undetected. So we can combine the advantages of radar and Wi-Fi with software-defined radio. You might be aware with software-defined radio with SDR, the changes that you make at software level, it is reflected at hardware. So it uses FPGA. So what you can do, we can mimic even radar, design the transmitter and receiver, which we have designed the transmitter and receiver of radar and Wi-Fi. We have combined the advantages of both. because we can, according to the application, we can increase or decrease the power level. We can change antennas as well. We can even change the frequency. So there are so many advantages that comes with, because it is flexible, it's scalable. So that's how one of our PhD projects is working on. So he's working on recording data in similar environment for all these three sensing techniques, and comparing like which technology would best suit. Yeah. So yep. At the top side, these are all like different breathing patterns that were acquired using. Yep. Can you okay. Okay. So this was like pretty much discussion on the ongoing research work that we have done using different techniques for past few years. The next generation technology that we are working on, that is using intelligent reflective surfaces. So what it will do, if the intelligent reflective surfaces, they are nothing but they work like these radiators. So these are similar to mirrors that are deployed at our homes. So what it can do, it can steer these radio frequency beam to a particular area of interest. Say if you want to monitor person A and B in a room, and not C. So any person under test A and B, they will steer these mirrors will, or these intelligent reflective surfaces will steer the radio frequency beam toward particular area of interest, and we can monitor like vital signs such as breathing rate, cardiac rate, human activities of daily living. So this will be the next generation sensing system, like radar, software-defined radio, or Wi-Fi. It will be coupled with these intelligent reflective surfaces. Yeah, can move to next slide if we have something. Yeah, so that's the whole summary, that we can use the ubiquitous radio frequency or wireless signals that are present everywhere, and we can monitor activities of daily living, or even we can monitor breathing rate, or cardiac activity, gestures as well. Um, Specifically, I think the use of this technology has become, I think, quite significant in COVID circumstances. For instance, if you want to monitor a person a COVID person suffering, for instance, in ward environment at home, you don't need to deploy any wearable sensor or person body, so you can remotely monitor their vital signs. I think COVID, yeah, it has become. Yes, it looks fascinating technology, but I think still we are a long way to go. I think after 8 years of working in this technology, I can confirm that we have just like scratched the surface, and we are still long way to go to use the RF sensing technology in clinical application. But I think we are moving in right direction. Yeah, that's it from my side. Yeah, thank you. I think we have some.
Thank you so much. It was really insightful. So, questions. So we have questions here. The people, any question? So you guys can, on those who are on the WebEx, you can open your mic and can ask questions, or you can type whatever way you like.
Yeah, I have one question.
Okay.
Yeah. So, how you can handle sensor fusion for multiple people?
Yes, so you mean like instead of monitor single participant, if you want to monitor participants,
Yes,
yeah.
but for the sensor fusion, like if we have multiple sensors, then we have also multiple user. So how you are handling this?
Yeah, so this is my ongoing project that will start from January 2023. It is an untapped area. So my another project is working on presently, because all of the experiments and the work we have done, it is for single participant in a very well controlled environment. So like you said, in a heterogeneous natural settings, my another project, it will commence in January 2023. So I will certainly put that. So I would like to keep it, because since we are in process of signing the contract, yeah. So I would like to leave your question, and then I'm happy to answer it like in
Yeah,
January.
thank you.
Right.
Yeah.
Yes.
Yeah, can you hear me? Because
You can talk.
yeah, okay. Thank you, Dr. Aziz Shah, for a nice presentation. A brief introduction of myself. I am Dr. Nadeem Iqbal, a Fulbright Research Fellow. Actually, my research and your research is aligned because we are, what I'm using is human activity recognition using wearable sensor. Actually, our goal is to design a smart prosthesis. The person who lost their limb, and we have designed a smart prosthesis so we can recognize their activities. Activities such as walking, stamp, ascending, sit, and step. So we can design all this. So it's a very interesting talk. So my question is related to, I have a couple of questions, so I will go one by one. So you mentioned about radio frequency, and could you tell us which technology is better, either variable sensor like IMU sensor for activity detection, or RF sensing, or SMG sensing? So which would is recommendable for activity recognition? Especially you talk about the Parkinson gate freezing. So in that prospects, what's your thoughts on that?
So definitely, I've been working on RF sensing for past 8 years. I'm a huge advocate of RF sensing, completely non-contact, no visuals, no audio, no images. However, I think we are still long way to go to use this technology in clinical settings, because even it comes with a lot of limitations, this technology, but like Wi-Fi and radar. But if you compare all like I have previously explained, software defined radio, it combines the advantages of Wi-Fi and radar sensor. So software defined radio is something I would recommend. Yeah, but yeah, there are some issues like presently we are facing, for instance, multiple participants. And yeah, for we have done some multiple participants, but all of the experiments we have performed, they are in a very well controlled environment, not in natural settings. Yeah, but I think, to be honest, we are still long way to go, maybe 10 to 15 years. But definitely, I think this is the next generation. We are also working on intelligent reflective surfaces as well to incorporate that and see how it can improve our performance in natural settings. But certainly, I'm big advocate of non-contact radio frequency sensing.
All right. So I'll come back to you. Let's take some questions from here. So we have the questions on the WebEx. Are you using body sensor transmitters or the actual body for position, activity, motion detection, or both?
So say again, please.
Are you using body sensor transmitter or the actual body for position slash activity, motion detection, or both?
So we are using completely like off body sensors like radar. It is completely non-contact and non-invasive. So there is no need for interaction from the end users. Similar with Wi-Fi as well, and STR. So that's our agenda. So we want to develop this system to be completely non-contact. So that like there is no engagement for active engagement from the user.
All right. So I had a similar question. Thank you, Dilip, for asking. Is your approach similar to that the Dana Kitabi at MIT? You know the professor Kitabi? He's using a similar kind of, the for the infants. I guess the detection of, for example, the ICU, they detect that whether the baby is breathing or not, or what level of breathing using the sensor. So I think the question is relating to is your approach similar to that?
Yeah, I think I know them. I know them because we started off at the same time, this work. Yeah, so there are, I think, quite few, like handful of researchers. MIT is one of them working in similar area. So in UK, like we are in a unique position. Not many people are specifically working on this area. But yes, I think we are using the same technology, Wi-Fi, for monitoring. So it is just application. Like if you want to monitor an infant baby or an elderly person, so these are like different applications.
Yep. So
But the
only
limitations come
in
with the technology, and yeah.
Yeah. Can you switch off?
okay.
Okay, so thank you again for giving me the opportunity to ask the question. So one of the questions asked by Dana Kitabi, they recently their paper regarding to Parkinson detection from the breathing using wireless technology. That is a very exciting research. So my question is related, in the same, we have feel the same problem, fusion of the data. Like in our case, we have IMU sensor, we accelerometer, gyroscope, SMGs, have a different data variation. There's a lot of variation. So in the sensor fusing of you have also different sensor you are using, Wi-Fi you are using, RF are using. So how you can fuse them? So in our case, we propose some convolution neural network model. So I could like to share that with you sometime, and if we have
Yes,
talked,
of
so
course, sure.
we can fusion them because we have different sensor have their own modality. So we have combined them and making a fusion system. So that work is not we have presented in any journal. So that's work we have. So what's your technology are using for the fusion at this level?
So we have used like the existing machine learning and deep learning techniques. So the variables, yes, we have used accelerometer, gyroscope, magnetometer. We have used it as a reference, but not specifically. Yes, the data that we acquired. So what we did previously, we simultaneously recorded like activities with radar, SDR, and Wi-Fi, and then we plugged all simultaneously, labeled them, like plugged into the classifier, labeled them, and then compared the results. So we observed when you combine the data, like train the classifier with different RF sensing technologies rather than individual one or two of them. So the three of them, it gives a better results. So I think, but the one that you're using, I think the concept is the same. You're just like plugging in the data to the classifier. The limitation is not in the classifier. The limitation is in the technology in itself, like Wi-Fi, SDR or radar. So we are working on developing some advanced signal processing techniques as well to mitigate, for instance, to disentangle like activities of subject A from subject B to subject C. But I'm happy to share some further information. Yeah, um, we have proposed this in our new project, so that's why I wouldn't be able to disclose or reveal so many things at this stage. But certainly, I'm happy to have a word with you.
Yeah, okay. Looking
Well,
forward.
my personal thinking is the limitation is not in the fusion. It's in the signal processing techniques, like one step before. So I
Yeah,
know, like
that's what we
with
call pre-processing at this stage. So
yeah, I mean it's not the limitation. Machine learning, like one step
no,
before, it's with the signal processing techniques. I'm
yeah,
happy to have a word
exactly.
with you individually. Yeah.
Yeah, exactly. So our model is slightly different. So we use both the convolution network for feature extractions, and also we use for the classifier. So we have different variations in the signals, different frequency bands. So that's why we make a combined features, and then later on you can use. Yeah, I agree with it. This is the issue is not in the classification side. It's more over towards the combining them
Signal
into
processing.
as a
It's in the
feature, one
signal
feature
processing
inside.
technique. Yeah.
Yeah,
We need to
we can
develop
talk it. So
algorithms.
yeah,
Sure.
I am also looking forward to cardiac activity like breathing analysis of using RF. So that's I'm looking forward to work
So
and talk to you inshallah.
I'm typing my email address here, so you may send me
Yeah, thank you.
email. Yeah.
All right.
Yeah.
So we
Next
have
question, please.
We have the question here. So how does this differ from monitoring that was used during the Apollo space program to monitor the astronauts? And then further, that was in 1970 technology. Certainly, newer technology is being used for monitoring during new space flights. Do you interface with NASA?
No, I have no clue about the Apollo trip. I've just like heard about the movie. I think so, but I'm completely naive about the Apollo space program. To be honest,
Okay.
I have no clue about it. Yeah.
Yeah, I have another question. Like, what I see the applications that you have is mostly indoor applications, right? So,
Yeah.
for example, if you want to fall detect, the all the sensors, the people they are using wired or wireless, they are using controlled and indoor environment. What would be the case if person is like uh, outside and for example, and older adults, if just like the fell down, or what would be the other way, like how we could use the technology, or what are the at this time the limitation of technology that we couldn't use? For example, what I was thinking, probably it would be an interesting idea. At this time we have the Teslas and these cars around. So Tesla is very, very heavy, the computers, the processing powers, they also have the signals. So just like, or maybe using the cell phone network, just like the people they use in the Google for the traffic jam, they check there the number of the how many Androids or Apples are at the same locations. So for using that sensors, can we detect the fall outside? So how when there is no particular sensor deployed available, can we use existing network to detect the foul or any other applications outdoor?
Yeah, I think you must have seen, like for instance, with radars as well. Like radar can detect even, like it can, if you're driving a car. So the cars these days they have lidar and radar, so they detect like objects and distinguish cars from people, trees, and so in radar can be used in outdoor environments. So is the SDR as well, as long as the person is in its range. Um, in backyard at home, I don't know what do they call backyard in US, but here they call it backyard. So you can deploy this in your backyard, SDR or radar. But if you talk about like, I don't know, somewhere,
Roads,
yeah,
roads, or somewhere in the mall,
where? Sorry,
like in the shopping mall, just to.
Shopping mall. But the issue would be there are so many people walking around.
Mhm.
But we haven't tested this technology that what what is the maximum number of people that we can monitor. In my proposed project, what we have proposed that will start, which I've mentioned several times, it will monitor what we have proposed maximum of 3 people. In shopping mall there's so many people. Yes, it can detect like fall, you can treat it as an outlier. And then if someone is like bending down to pick up something, but clearly you can distinguish like bending down from fall, so you can treat it as a binary case, fall as an outlier, and then rest of the activities as class B. Class A, walk, sitting down, standing up, walking back and forth, running. Mm, you can treat it as class A, but fall you can treat it as class B. So this is how you can, if you treat fall as an outlier, but that would only give you like the binary case.
I see.
It can detect, but yeah, in binary case, yes, you can. If you treat all other activities, leaving fall out as class A and fall as class B, then you'll be able to pick up. But I'm not sure what's the maximum number one can. I know in cars these days they detect like if you treat like different cars and humans as objects, they detect when they are in their range. I assume with Tesla as well, they have this technology. But yes, you
Yeah.
can answer to your question. But we
I
haven't
see.
like personally explored that area.
Sure. Thank you. Any other questions here and on WebEx?
I have a question, and I'm
Yes,
probably
please.
the only healthcare provider in the room here. I'm actually a pharmacist, and this remote monitoring sounds really helpful. So this type of I'm trying to understand because I'm not a tech person. So radio frequency, I think of it as being available everywhere, but this also depends upon Wi-Fi. Is that right?
Yes.
Okay. I just wonder, the problem we have in some areas of the United States is there are underserved areas that do not have Wi-Fi at all. And so they can't use a cell phone or anything like that, but they all have radios. They can all get radio. And I was thinking this would be great if for those particular places where we're just, I mean, in Appalachia, we're probably not going to get Wi-Fi for everybody. And reaching those people that are hard to reach, this would be ideal. Is there any way to do this without Wi-Fi?
Radar, you can use it, but you need these sensors particularly to monitor people. Like without, if you don't have Wi-Fi, then you can deploy radar as well. It doesn't need any internet connection, by the way.
It doesn't need, so if you have, okay, so like a satellite, you're saying, is that, am I correct? I'm trying to understand again.
Not satellite, but maybe you need to deploy a radar, like to, if you don't have Wi-Fi, to monitor people. Because I understand with software-defined radio, if you use it as a receiver, I have seen in literature, people have used mobile phones as transmitter and then a software-defined radio as receiver to monitor different activities. Personally, I haven't tapped that area, but in literature, I have seen people doing that using mobile signals. But still, you would need software-defined radio to receive.
Yeah, I was just trying to think of how to reach the people who are not, who just don't have access. And it's not only in America. I'm sure there's a lot of other countries where there's a group of people that just do not have access, and that's always the challenge for healthcare providers is the people who come in, you're preaching to the choir, so to speak, but the people who have a hard time getting there or just communicating, those are the ones you really want to reach, and those are usually the ones that need it the most. But this is really, really interesting. It makes me excited about what else you guys are going to create to help us out in taking care of our patients better. This is wonderful. Thank you.
Thank you.
Any further question? All right, so if there is no further question, let's thank our speaker and apologize about the connection issue. I think that's my mistake. I should have tested before. Anyways, we record our sessions, and the session will be available. So by tomorrow or day after, I will post that on our university and website and Twitter handle as well. And if you are interested, I will also post on the LinkedIn. So if you are interested, please ping me, or maybe you will find that through. Usually, if you are signed up, we send the link through email as well. Thank you.
Yeah, thank you all for listening. Yeah, really appreciate for inviting me. Hope to see you soon, sometime.
Yeah, sometimes next year. Yeah.
Thank you.
Looking forward to your visit to New York.
Yeah.
Bye.
Thank you again. All right. Thank you.